fascinating discussion so far today on UTM and some of those, the big overall framework of what will be needed for UTM, as well as challenges going forward, how we're going to implement all of this, what it's going to take, along with some of those things about what it should not, or what should not get in the way of implementing a UTM system. Well, one of the things that we need, of course, is a communication system that's going to be able to work. And in order for a communication system to work, we need to know about the frequency spectrum and the capabilities that will be available. So we reached out to our colleagues over at our sister organization in the UN, the International Telecommunications Union. We have a very strong working relationship with each other on many of these subjects. And luckily, we did get a speaker to come join us, Mr. Nikolai Vassiliev. He is the chief of the Terrestrial Services Department in the Radio Communications Bureau of the ITU, where he deals mainly with frequency spectrum issues of terrestrial radio applications, including the aeronautical ones. Nikolai has worked in the ITU for 21 years and is a member of ICAO's Frequency Spectrum Management Panel. So as I said, we work very closely together on these aviation and spectrum issues. So Nikolai, may I please have you join us?
Thank you. Thank you very much. Good afternoon, ladies and gentlemen. This session is named Background, but please don't worry. I will not tell you about background and the history of all radio communications since invention of radio. But still, let me start with presenting my organization, ITU. We're the oldest organization in the UN family, based in Geneva, around 750 staff, quite multinational. My department consists, for example, of 32 persons and 27 different nationalities there. I do have three main sectors. Radio communications, I work there. This sector deals with allocation of spectrum and also development of standards for wireless communications. The second sector, ITU-T, standardization, they're producing standards for core or wired networks and development, dealing with assistance to administrations, especially of developing countries. At this slide, I would like just to show you how radio regulations look like. This is Red Book, 4 volumes on the right side of the slide. It was born 111 years, and over all these years, it was built to meet the emerging wireless technologies. So radio regulations is international treaty. It's ratified by governments, and then the provisions of this treaty translated into national legislation and becoming mandatory for application by countries. The radio regulations allocate the bands, frequency bands, to different services. There are around 40 services: maritime, satellites, radio navigation, location, aeronautical, and it has two main goals. The first goal is to ensure interference-free operation of station. I think it's quite important for your community, for US operations, because the loss, interference means the probable loss of the link with aircraft and potential loss of this aircraft. So the second goal is harmonization of spectrum. It's also important for ICAO because thanks to this harmonization, all aeronautical safety bands and bands used for air pass are harmonized, and this allows aircraft to operate everywhere using the standard frequency and standard equipment. These radio regulations updated every 3 or 4 years at the World Radio Communication conferences. And the first conference which dealt with aeronautical frequencies was in 1927. And then after that, practically all subsequent conference was allocating spectrum for emerging emerging aeronautical technologies. If we take example of the last two conferences, WC12 allocated spectrum for terrestrial component of AirPass in 5 gigahertz band, and the last conference, which was in 2015, it provided spectrum for global flight tracking, for satellite reception of ADS-B signal, for wireless electronic communications, this service Wi-Fi in the aircraft to replace cables, and it also designated 8 frequency bands for satellite component of AirPass, enabling the long line of sight operations of this AirPass equipment. Just to give you the idea about the scope or the scale of the conference, last conference was attended by 3,300 delegates, 163 countries, 4 weeks of work, more than 600 documents there. So what are candidate bands or potential spectrum for US? I would subdivide this spectrum into 3 categories. First is aeronautical safety bands. The majority of these bands are exclusive bands, so nobody is there except aeronautical. This is the beauty of these bands. So they're protected from interference. This is thanks to coordination and careful planning of these bands. They're managed by ICAO and also by civil aviation authorities. One of these disadvantages, they have quite limited capacity, and currently they're already intensively used. The second category is licensed bands, not aeronautical, but still which operate under license. And one example is cellular networks. Normally these bands shared with other users, but they have sufficient capacity in terms of frequency, bandwidths. They have control of interference, and certain quality of service is ensured there. And the last category is unlicensed bands. For example, Wi-Fi for short-range devices bands. There is no individual license here. There is generic conditions, and mainly it's limitation of power. For example, 0.1 watt, not more. And because of these limitations, they normally used for short-range communications, tens of meters, 100 meters, something around this distance. Advantages, they have quite good capacity, and they're free to use. No payment, no license necessary. Disadvantage is the quality of service. It's not ensured. Interference are possible in these bands. So let's consider these 3 categories as candidate bands for US. If we take aviation safety bands, the main question, there are even 2 questions. The first question, are they suitable for US? And the second question, are US are welcome in these bands which are used by civil aviation? So HF band is megahertz, long distance communications. I would say no, because they're congested, they're subject to careful planning both in ITU and ICAO, and there are no resource there. VHF bands, this is voice and data communications between pilot and ground. Again, in principle, these bands are very intensively used, and because of that, there is no possibility to use them for US. L-band, 960, 1164, this is different aeronautical equipment operating there, so, but purely aeronautical, exclusive aeronautical bands, including ADS-B. Again, the conclusion of the frequency spectrum management panel, this is not my personal conclusion, so in principle, not available, with exception of course, ADS-B, which, as you saw in previous session, may be considered. At least the concept and maybe frequencies. And C-band, this is a band which was just allocated for mainly AirPass, terrestrial component. It could be studied. In some countries, it's already tested for US equipment there, and it has some potential. The only problem is quite limited. You see it's only 61 megahertz. So we don't know right now, is it enough for both, for AirPass and for US. So unlicensed frequency bands. Here I would again divide these bands in two groups. The first group is industrial, scientific, and medical applications, and the list of these bands can be found in radio regulations, maybe around 20 such bands listed. They include Wi-Fi frequency, 2.4 and 5.8 gigahertz. And short-range devices, bands, these bands used for alarms, for RFIDs, wireless microphones, which you can see here, for these short-range applications. Normally, these bands are harmonized regionally to get sufficient market for it. The advantages of this band, as I already mentioned, good capacity and freedom to use. But the main disadvantage, no license, so no conditions to respect other users and to protect your Wi-Fi or something. As a result, no interference protection and no quality of service which is ensured. So as a result, these bands, unlicensed bands, I think could be used mainly for recreational US within line of sight distances. It's also a good possible solution for US identification and tracking, and we saw it especially in the session this morning and this afternoon. Like Wi-Fi beacons or similar equipment. But these bands may be not suitable for below line of sight communications and for professional US, which require higher quality of radio communication channel. So the usage of these bands varies by country. Some examples are here. So the third category is licensed bands, and the first application which comes to the table for discussions, it's IMT. It's ITU term for international mobile telecommunications. You may know them as 3G, 4G, future 5G networks. We allocate spectrum for this application and harmonize the bands for them, and also develop high-level standards for these IMT standards. There are several visible advantages of these bands, and they have huge capacity. After last conference, we have almost 2 gigahertz of total spectrum for these applications. The harmonization is quite good, totally 65% harmonized globally, worldwide, and some key bands, including golden bands like 700 megahertz or 3.4 gigahertz, they harmonized worldwide. IMT parameters, if we look at parameters, they could meet US requirements for C2 links and even payload. If we take, for example, the parameters of next generation 5G generation, so you see here user data rates very high, latency it's up to 1 millisecond, so latency critical for US and other high reliable applications. Mobility, they can support applications or devices which move with the speed up to 500 kilometers. Connection density up to 1 million devices per kilometer, and this is to accommodate Internet of Things. There are other IMT advantages. They're quite large to accommodate both C2 link and payload at the same time. And this is important because sometimes there are carriage limitation for US. Small drone cannot just afford to carry several sets of radio equipment on the board. Ubiquitous coverage, it means that they're almost everywhere. Potential for tracking, US, similar to mobile phone, so Our mobile phones are tracked by SIM card, which is inside. The same idea can be used for drones. SIM card installed on US aircraft. They're harmonized, which facilitates trans-border operations, and they will evolve to integrate into so-called heterogeneous networks, when all networks will be used in the one, let's say, seamless way. So cellular plus Wi-Fi plus one max fixed. Some features, by the way, we have already now. You have your mobile telephone, you go in the street and it talks to base station, nearest base station. You go inside the building and switch to Wi-Fi, which is inside. So this is the first features of heterogeneous networks. So, but they are not perfect. There are still uncovered areas in coverage, especially 3G and 4G. 2G I would not consider for C2 links because channels are too small to transmit necessary amount of information with required rates. So ITU statistics says that the coverage from country to country varies from 40% to 100% of population. Unfortunately, we don't have statistics for coverage by area, but if we take example of host country, Canada, the host country coverage is 99.3% of population, but the remaining 0.5% population may live in very large areas without any coverage. So it means drone cannot go there. Then network topology, it's not ideal for drone because the idea of base station that they serve the land, not sky. So from this point of view, antennas are oriented towards the ground or horizontally. They not serve the sky. So there may be some question with quality of service at the edge of cells. Then and quality of service, in some cases, may not meet the US safety requirements. Again, if I go to the statistics, ITU statistics, we have one indicator which measures quality of service. This is current mobile cellular drop call ratio. It means link established, you may call, link established, but because of technical reason it's dropped. So it varies from 0.01% to up for one or two countries up to 3%. So here may be a question with quality of service. Are there solutions for some of these disadvantages? Industry says yes, and they point us to the 5G generation, and this generation, they claim, will be wider than just mobile industry. It will accommodate so-called verticals. It's industry sectors, and some examples are on this slide. This is automotive application, railways, media, Internet of Things, public safety, and drones, they say, will be covered by MT, 5th-generation networks. So we have one very powerful standardization organization. This is 3GPP, which combines six the biggest telecommunication standardization bodies from different regions, and they, together with some big telecom players, they say they started standardization of IMT for drones. So as you saw from the previous slides, there is a variety of possible bands and possible technologies. What to choose, how to choose from these possibilities. One possible approach is just to categorize UAS and define requirements for each category. Requirements in the terms of operational range, line of sight, beyond line of sight, and quality of service, which is also important. And the choice of technology will depend on these requirements. So you may choose technology with meet requirements for certain category of UAS. As for spectrum, again, as summary, licensed spectrum or dedicated bands could be used for, especially for professional US and for loss operations, and unlicensed bands for recreational US operated and in line of sight distances. And again, there was several very, very interesting presentations, and we saw that some of these bands and some of these technologies can be combined. For example, this signal which is broadcasted, then received by Wi-Fi, and then go through IMT or 5G networks to your iPhone there. So this option of combination of several technologies and several bands also should be considered. Maybe my final remarks, final comments, it's about international cooperation. As you see in the US activities now, there are so many players and so many directions that coordination of these activities becomes critical. If we take example of studies on spectrum and technologies for USC toolings, they're taking place both in ICAO and outside. And outside aviation community, I would say in several regional telecommunication organizations like CPT, they're taking place in 3GPP and big telecommunication manufacturing companies. They're trying to consider how to accommodate US under 5G. And in ITU, there is study group 20 dealing with Internet of Things. They have some very, very preliminary proposals on identification of UAVs as digital objects. So it may be useful then that ICAO and advisory group will keep eye on these developments to avoid duplication, maybe to avoid deviation from the mainstreams of from the interest of aviation. We saw in the past some deviations which took us time to fix them. And as for possible assistance of ITU, I'm speaking about radio communication sector. I was looking for possible what we can do for you. So two things that if IMT is chosen as one of platform for command and control links for UAV, we can help in adapting regulations, because some IMT bands now are not allowed for aircrafts. They're allowed only for land mobile service. So, and if decided to make a harmonization of this band, especially global, we again can help here. We already harmonized bands for many, many technologies, public protection, disaster relief, electronic news government, now for railways, for also for intelligent transport system, we're doing this harmonization. So we're ready to help and to do it for you if it's necessary. Thank you very much.
Thank you, Nikolai. Thank you, Nikolai. That was excellent. There's a lot of background information that we really do need to be aware of as we are looking at technologies to make this industry function. We need to know both what our constraints are as well as where the openings are for moving forward. Now, I did receive a question from the audience, so I would like to put this forward to you. Could you expand on some of the driving reasons why unlicensed frequencies would be considered unsuitable for operations beyond visual line of sight? So for the unlicensed frequencies beyond visual line of sight.
The first reason is, again, quality of service, which is not ensured there. So for unlicensed bands or equipment, we don't know how many users use the particular band at given location at a given time. There may be nobody there. There could be 1,000 Wi-Fi applications there. And example from at the, I would say, life, from our life, if you have a building, for example, and there are many, many Wi-Fi networks, sometimes the speed of downloading of internet pictures, it may be very, very low. You can be even blocked with this. It means that how Wi-Fi works, it's so-called dynamic frequency selection. It looks for available channel, free channel, and it takes this channel. And if all channels are occupied, it waits. And this waiting time means that during this time there is no signal. So if you send command to drone, turn to right through Wi-Fi, and there is congestion at this time, it may go forward. And when the signal comes to this drone, it's time to go to left, not to the right. So quality of service. And the second, I would say there is no ubiquitous coverage of Wi-Fi or any other unlicensed networks. IMT, on the contrary, they have this coverage practically, okay, not 99%, but everywhere. Wi-Fi, it's mainly in the cities. So if you send drone to rural area, there is no infrastructure to operate.
All right, thank you very much. That was very, we need to know this information. Again, everybody. All right, so that concludes our proceedings for today. I want to thank all of you that have sat here paying such good attention. And we've been able to see, sitting up here, your faces primarily focused up on the screens and at the speakers. Nicely done to all of you. So, a round of applause to our audience. And to anybody who may still be watching us online as well. Okay. So, a couple things. Rather than trying to recap today, because there was really just so much information, that would be too challenging to recap at this point. So instead, I'll look forward to tomorrow. When you come tomorrow, we have 3 streams set up for the morning session. One on the communication system, one on geofencing, and one on registration, identification, and tracking. Now, this assembly hall will be split in half. We have a wall that comes right down the middle. This side of the assembly hall is stream A. That will be on registration, identification, and tracking. So if that's where you want to spend your time tomorrow morning, come here to this side. Over on this other side of the assembly hall, we will have the communications discussions. All the different possibilities that are being presented to us on how the communication system that facilitates all of unmanned operations work. Then down on the first floor, if you want to be in the geofencing-like systems room, that'll be on the first floor, and there will be indications, signs of where to go. So we will be starting tomorrow morning at 9 a.m. You will have 3 members of the RPAS team who will be providing Master of Ceremony services, so you'll get to see some new faces. And we look forward to seeing you all then. Now, for anybody who wants to download the presentations from the RPAS symposium of the previous 3 days, besides the fact that they are on the app, they are also now on the meeting website. So if you go to the meeting website, you will find them there. However, the meeting website has been moved into the list of past meetings as opposed to upcoming or current. After all, it ended yesterday. So they are all available. And with that, everybody, please have a wonderful evening. We'll see you back here 9 a.m. tomorrow morning. Thank you.